Alright, we're doing out this problem called rotate image. You're given an n cross n 2D matrix representing the image. Rotate the image 190 degrees clockwise. You have to rotate the image in place, which means you have to modify the 2D input matrix directly. Do not allocate another 2D matrix into the rotation. Yeah, I got it. That's what in place means. Okay, so this. 1 to 3 shift it 1 to 3, 4, 5, 6 becomes 4, 5, 6, 7, 8, 9 become 7, 8, 9 like that. How can we do this without um, without any like how can we do this in place? Okay, let's switch to whiteboard and see what we can do. So what we want is, so what we're given is uh, 1, 2, 3, 4, 5, 6, 7, 8, 9 at P, and what we want to reach is when you rotate it 90 degrees. So 1, 2, 3 comes here. This 4, 5, 6, when you rotate, it comes here, and this 7, 8, 9, when you rotate, it comes like this. So essentially, what's happening is this row is becoming this column, and this row is becoming this column. How do we solve this? So when row becomes column, that's what is called transpose in matrix. But when that happens, the first row became first column, but here the first row is becoming the last column. So if you first think about transpose, so if we were to do transpose on the matrix, right? So if this is A and this is A transpose, then the first row becomes first column. So that would be 1, 2, 3. Second row 4, 5, 6 becomes second column. Third row 7, 8, 9 becomes this. So let's say somehow we could do transpose, and then from the transpose, what do we can we reach here? And if you see what's happening here is first row is 147. Here the first row is 741, right? So essentially, if you reverse the rows, 258 you make it 852, 369 you make it 963. So if you can first do transpose and then you can do reverse of rows. Now row reversal is something quite basic, right? I go through each and every row and reverse. That I can do. How do I do transpose? So let's look at this 0, 0, 0, 1, and this is 1, 0. 0, 0 remains at 0, 0. 2, here 2 came at 1, 0. And 3 came, sorry, yeah, this is 1, 0. This is 0, 2, my bad. This is 0, 2, and it becomes 1, 0, and it becomes, hold on. Isn't, is, is transpose just a swap across this diagonal? So 1, 5, and 9 remains 1, 5, and 9, right? And then 2 and 4 is swap, becomes, then this 3 and this 7, oops, swapped, and then 6 and 8 swapped, right? So what's happening exactly? That's what transpose is, right? Transpose is A of ij equals to A of ji. So how about we just keep swapping? I think this is something that we have to more think a little bit more on. So we go through each and every, so we go through row by row. Oh no, we don't even go by row by row. We just go by one of these triangles, right? So essentially this is your matrix and this is your diagonal. So either you go through these or you go through these and you do the swapping, right? And the swapping is so essentially let's say if you go I equals to 0 to n, just consider it's a square matrix, then for each I, j will go from 0 to I only, right? That's the idea. So this, then you will essentially are going through this, uh, you're going through the lower triangle. I think I got the gist. Let's go back to the code and rotate the array. So we do two things. One is we do transpose, and after the we transpose, we do reverse rows, right? That's the two things that we are doing. Now, reverse row is just quite basic. So let's implement that first. So for I equals to 0, I is less than matrix dot length I equals plus L equals to what, 0, and R equals to again matrix I dot length minus 1. So you have L and R. While L is less than R, you want to swap matrix of you pass in matrix of I, or just yeah matrix. Swap this. Why don't we just swap? Okay, so in temp equals to matrix of IL, and then matrix of IL equals to matrix of IR, and matrix of IR equals to temp, and then you do your L plus plus and R minus minus. This is your reverse rows. Now let's also implement transpose. So transpose the matrix as we talked, we'll go to the lower triangle, which is for I equals to 0, I is less than j equals to, in fact, like to be more smart, but okay, the diagonal doesn't change, right? So I could even do I equals to 1. Like the first guy will only have single and no change, right? So, and then j equals to 0, j is not equal to, because equal to again, so j is less than I, and J++. No, you want to swap A of ij and A of ji. So right, this is now let's run code and see if it really works. And it does. Submit. All right.